This video details some of the extension activities you can perform when trying out the NASA Make a Mars Helicopter activity with your students. In this video, we show how to modify your helicopter to change the outcome of the experiment and test out these modifications to show you our results. You will need to use this provided template to cut out and modify your helicopters. For the first exercise, I altered the length of the helicopter blades. The helicopter on the left has blades that are half as long as the regular helicopter, while the helicopter on the right has blades that are 1.5 times as long as the regular helicopter. I will be comparing their performance against each other and against the regular lengthed helicopter. As you can see, the helicopter with the shorter rotor blade fell faster than the helicopter with a regular blade length. The opposite trend occurs here. Now, the helicopter with the longer rotor blade fell more slowly than the helicopter with the regular blade length. Overall, shorter blades help the helicopter fall faster than longer blades. These results are shown more staggeringly when comparing shorter versus longer blades directly. For the second test, I altered the angle of the helicopter blades rather than their length. The helicopter on the left has blades cut at a larger angle than the regular helicopter, while the helicopter on the right has blades cut at a smaller angle than the regular helicopter. I will again be comparing their performance against each other and against the regular angled helicopter. It is clear that the helicopter with the larger rotor blade angle fell faster than the helicopter with the regular blade angle. Surprisingly, there was almost no difference between the speed at which the helicopter with the smaller rotor blade angle fell and the speed at which the helicopter with the regular rotor angle fell. The helicopter with the larger rotor blade angle fell slightly faster than the helicopter with the smaller blade angle. The difference in speed was not as noticeable here as in other experiments. For the last test, I altered both the length and angle of the helicopter blades. The helicopter on the left has shorter blades cut at a larger angle, while the helicopter on the right has longer blades cut at a smaller angle. I chose these experimental combinations because I observed in the previous tests that both shorter blades and larger angle cuts resulted in the helicopter falling faster, and both longer blades and smaller angle cuts resulted in the helicopter falling slower. Therefore, I should have created the fastest falling and slowest falling helicopters possible. I will again be comparing their performances against each other and against the regular helicopter. As you can see, my prediction was correct. The helicopter with shorter blades cut at a wider angle fell substantially faster than the helicopter with longer blades cut at a smaller angle. It appeared that the helicopter with longer blades cut at a smaller angle fell at a similar speed to the regular helicopter, although occasionally slightly slower. However, we found that the helicopter with shorter blades cut at a larger angle fell much faster than the regular helicopter. The general trends of these experiments were as follows. Shorter blades helped the helicopter fall faster than normal, while longer blades caused it to fall slower than normal. Blades cut at a larger angle helped the helicopter fall faster than normal, whereas blades cut at a smaller angle didn't really affect the rate at which the helicopter fell. It reached the ground at about the same time as the helicopter with regular blade angles. Overall, it appeared that blade length made a bigger difference in helicopter speed than the angle at which the blades were cut. There are other characteristics besides just speed that make a helicopter's performance better or worse. You may also choose to take into consideration how straight and/or consistently the helicopter fell, or whether its path was smooth or wobbly.